Okay, so you've been doing some of the formulas for a while, and now we're going to look at how we can do some more complicated formulas. That's ones with have squares and cubes, so it's c to the 2 exponents, c to the 3 exponent. How do we deal with that? So I'll just put a couple of simple examples down. Here's the first one. What that means is the area equals the side squared in a square. And once again, you don't really have to know the geometry. It won't hurt because you're going to have to know it later in other modules. But right now, just to know that how to solve the letters given one of the letters. So this time I'm going to say that the sides are 5. You know, in a square, all the sides are the same. So all sides are 5. And what is the area? So what the area would be, of course, as before, we take the same formula, and since s is 5, instead, these look the same, of course, especially the way I write, but I'm going to put a 5 in instead of the s. So now instead of saying area is s squared, it now says area is 5 squared. And just know that whenever it says squared like that, that is the 2 is in superscript, that doesn't mean 5 times 2, rather that means 5 times itself twice. So that comes to 25. And many calculators actually have a little key on it that looks like that. And that's what you can use to square. Although I would prefer, if you're doing these small numbers, to do those in your head and use your calculator when your head isn't working. So let's look at a more complex thing with the same one. We'll just get rid of this one right here. And actually, we'll just go backwards from what we just did. Exactly backwards. So supposing I say that the area is 25, and what are the sides? Well, of course, you know from what we just did that the sides are 5, but let's figure out how we would deal with that if we got that as a question and we didn't just do the opposite. So once again, we put the 25 in exactly where the a is in the formula. So instead of saying a is side squared, we now say 25 is side squared. Now here's the part we want to get straight. We don't want to confuse it with the previous one. The previous one was when we had 5 squared and we wanted to find what the area was, so we went 5 times 5. This is not what we do now. Right now, we know that the side squared is 25, and we want to know what just the side is. Before, we knew the side was 5, and we wanted to know what the side squared was. So this is exactly the opposite. We know the side squared, we want to know the side. What do we do? What really we're looking for a number that multiplies by itself to give 25. But here a calculator is rather useful. What you do is you use this key on the calculator. And we take square root of 25, and the calculator would then tell you that your side is 5. So a key just looks like that on the calculator. Some calculators you must push that key first, and then the 25, and then the equal. Other calculators you push the 25, then that key, and it comes up. So that I will just do a couple of slightly more complex ones, or one at least. So let's get rid of that one. Okay. And we'll try something that's just a little bit more complex. Not much, though. Okay. Let's go with this one. This is the formula for area of a circle. Again, you don't really need to know that, but I'll just tell you that the R, that's an R if you can't read my writing, stands for radius. And this thing pi, most people seem to know this, but it's always 3.14. I mean, some people 1.1416 and so on. Well, 3.14 is good enough. Every time we see that, that's what it's going to be. So we might as well say its area is 3.14 r squared. So the first thing I'll do is I'll do this, and let's say the same thing as we did in the first example, that the radius is 5, okay? So what would we do? We write the equation over, the formula, and this time we substitute everything we know. So we know pi is 3.14, so instead of pi we write 3.14. And realize when they're written beside each other like this that it means times. So it means 3.14 times r squared. And remember, well, we'll just write it like that first. We're putting 5 in for r. And you remember that what that actually means is that not 5 times 2, but 5 times 5. So we write that like that. And we get our answer, which I'm having to do this in my head, but it's 78 something. 78 point something is what the answer we would get. And remember again that you also, most calculators have this key on them, and either you put 5 in and hit that key, or you hit that key and then hit 5 and then equal. That depends on what kind of calculator you got. So we're going to erase this again and just do one more version of it, and then we're done. Okay, so let's, we know pi is 3.14, that's always the case. Let's say we know the area is 62.8. Seems a bit of a weird number, but I got my reasons for picking that one. So let's put it in. Again, we're going to write that same formula down. This time we're going to write the 60.8 exactly where the A was. So 62.8, then comes the pi, and then comes what we don't know, r squared. So we have a first step this time that we have to do before we go further is you got to do what you would say isolate this r squared. So it's not 3.14 r squared, but just r squared is something. The way we do that is just what you did earlier. Sometimes when the numbers are bigger and more complex, it's harder to think of it. But if I said 2x is 10, you would have easily went, well, x is 10 divided by 2. Same thing, only numbers are harder. So when we divide that, you will see you get a nice even 20, which is why I chose that number. So now we're at this point, and if you remember back from the first example, once we get to this point, our next step is to go like this. When we have the squared and we want just the r, this is what we do. And this is something, I cannot do this in my head. You have to use a calculator to do this, to get what the answer is. And I'm just going to pull out a calculator because I won't get it if I don't. And okay, well, my calculator didn't work too well, so I picked one of my duds. So you know what to do, and that'll be good enough for this lesson. I think that should get you through the squareds. We will do one on cubes a little later.